Dear students, welcome to my YouTube channel PCM Academy. Let us continue our lecture series on central force problem. In the last class we have discussed about the equivalent of one body problem and the concept of reduced mass. Today we will discuss some example based on this. So the first example that we are going to discuss about is the binary star, or you can say double star. Now before going to the detail of this, let us remind you what we have studied in the last class. So we have a coordinate system, something like this, and we have two objects, one of mass m1 and another mass m2. m1 have the position vector r1, m1 have the position vector r1, okay, and m2 have the position vector r2. Now what we have done, we have just tried to find out the equivalent of one body system of these two body. For that purpose, we have to find out center of mass between these two objects first. So we have chosen a point which is center of mass. So suppose that this is the center of mass, and the position vector of center of mass we can say this is r center of mass. Now we have choose this point as a reference point, and we have find out the equivalent mass of these two objects, that is mu, which is nothing but m1 m2 divided by m1 plus m2, and this mu is the reduced mass of m1 and m2, and the position of this mu with respect to center of mass, suppose that this is the position of mu, and the position vector of mu with respect to center of mass is nothing but r1 minus r2, and in that case this motion of mu can explain the motion of whole system, that is m1 and m2. So mu is the equivalent system of the two body system m1 and m2. So instead of discussing m1 and m2 differently, we can discuss the motion of mu only, and then we can convert the required result for m1 and m2 also. So that was the scenario that we have discussed in the last class. Now let us explain the motion of binary star with respect to this scenario. So we can easily explain the motion of binary star if you understand the equivalent one body problem or two body problem. So let us suppose we have two star, one have mass 2m and another have mass m. So what we have to find out first, we have to find out the position of center of mass. Let us find out the position of center of mass with respect to 2m. Instead, so first let us take the distance between 2m and m is r, suppose. So what will be the center of mass with respect to 2m? So with respect to 2m, the center of mass will be, suppose this will be just r center of mass, that is m1 r1 plus m2 r2 divided by m1 plus m2. So if this is the reference point, then the position vector of this is 0. So let us take r1 as 0. So 2m into 0 plus m into r, as this is r, so with respect to m this is r, and this is 2m plus m, so it will be just m by 3. You can r by 3, it will be just r by 3. So the position from here is r by 3, suppose this, okay. So this will be the less distance with respect to this, and this is 2r by 3. So this is the position of center of mass, okay. Now suppose that the mu here, what will be mu? Mu will be just m into 2m divided by m plus 2m, that is your 2m square by 3m, that means 2m by 3, 2m by 3, okay. So it will be where, suppose it will be here. So this is mu, okay. Now what will be happening? So if you consider the motion of mu, let us suppose consider the motion of mu, okay. So suppose the mass mu is from this point to this point, mu is moving from this point to this point, let us suppose. So it will be here. Now you have to remember two things about center of mass. The center of mass will always be fixed at its position, and it will lie along the line joining 2m and m. So when mu is moving from this point to this point, so 2m and m will take their position in such a way that the center of mass will lie in its position, initial position, and it will also be along the line joining 2m and m. So how 2m and m have to move such that they will be situated along this line. Okay, so 2m will move from this point to this point. Similarly, m will move from this point to this point. You can see. Okay. So you can realize that this 2m will move along this circle. Okay, with respect to center of mass. Center of mass will be this will be center. This will be acting as a center, and this 2m will be moving along this circle, and m will also be moving along this circle. So this will be just 2r by 3. The radius will be, this radius will be r by 3, and this radius will be 2r by 3. So if you again take one more position, so mu will be from this point to this point. So in that case, 2m and m will be such that 2m will be here and m will be here. So you can see that m will be moving along the circle which have radius 2r by 3, and 2m will be moving along the circle which have radius r by 3. So these two will be moving in such a way that they are always opposite to each other, and the center of mass of 2m and m will always be lying at its initial position and will be along the line joining. So this is the same thing if you want to consider the motion of mu, or if you want to consider the motion of 2m and m. So this is the equivalent of one body system, and this is the two body system. So this is how we can explain the motion of double star or binary star by using the concept of equivalent one body problem and the concept of reduced mass. Now there are a lot of examples for this reduced mass system, not only in central force problem in mechanics, but also in atomic physics also. If you talk about the motion of electron in hydrogen atom, if you talk about the positonium ion, so that can also be explained with the concept of reduced mass. But before going to that point, let me tell you about the motion of earth around sun. Why we take sun as a rest and earth is moving around sun? Why we can take this? This is because of the fact that the sun has very large mass with respect to earth. Okay, so in that case we can explain that thing also here. Okay, so suppose we have sun here and earth here. So let us take the sun has mass ms, which is very greater than the mass of earth. Now you can see one interesting point, that what will be mu in that case. So mu will be just ms into me divided by ms plus me. Now if you divide the system by ms, then we will get me divided by 1 plus me divided by ms. And as ms is very greater than me, so you can neglect this term, because ms will be very high, then me by ms will be tending to 0. So it will be just equal to me, almost equal to me. So you can say that the motion of earth, so if you talk about the equivalent this two body system, equivalent mass of this two body system, that is nothing but the mass of earth, only the mass of earth. Now what will be the position of this mass, or what will be the position of the center of mass? So you know the mu is moving with respect to center of mass, so you have to find out the position of center of mass. So with respect to s, if we take that the distance is r between earth and sun, and if this is taken as origin, so the position factor of this with respect to sun will be 0. So it will be just r1, take r1 is equal to 0, and if the position factor of this is r2 with respect to this point, so the r2 will be r, you can see. So what will be the position of center of mass? So the position of center of mass, if you talk about r center of mass, then that will be what? Mass of sun into 0 plus mass of earth into r divided by mass of earth plus mass of sun. Okay, so it will be just me into r divided by me plus ms. me plus ms. Okay. So now what we can do here, the position of center of mass, actually if you take that ms, if you divide this whole system by me, so what you will get, that you will get just r divided by me plus 1 plus ms by me. But you can see here, or you can write in this way also, if you want you can write it in this way also. This will be better, I think. Suppose r center of mass will be just, if we divide the whole system by ms, so it will be me by ms into r divided by me by ms plus 1. Now you know this me by ms we can treat as 0, so your r center of mass will almost equal to 0. So you can take the r center of mass is here, so we have mu, so the mu will be just the mass of earth. So you can see this is as mu, that is nothing but me, and this is the center of mass, and the position of center mu with respect to center of mass is this. So the only motion that we can consider is the motion of earth, and we can take sun as a rest, so that you can see the motion of earth is actually the equivalent motion of mu, almost equal. So for calculation purpose we can neglect the motion of sun, and as the center of mass is also almost at the point of sun, because we have taken the approximate value, so it will be almost at the position of sun. So you can say that the motion of earth can be analyzed with respect to this concept, that is equivalent one body system, and here the equivalent one body is itself earth, because here sun has no role, because it is huge mass, and the position vector center of mass of earth sun system is almost at the point of sun. You know from the general concept of center of mass also. So if you have two mass, one is capital M, this is a huge mass, and then small m, so the center of mass will always be tending to situated towards m, and if m is very greater than small m, then we can treat this point almost at the point of m. So this is why we can take sun as a rest. In the same region we can take the motion of proton in hydrogen atom. The motion of proton can be treated as a rest, because in hydrogen atom also, you know, so there is a nucleus where there is a proton and electron is moving around the nucleus. But you know that the proton has huge mass with respect to electron, because the mass of proton, you know, is 1840 times me. So here also the mass of proton is very high with respect to electron. So in that case also we can treat this proton as at rest. So the equivalent body of this two will be only electron. So electron will be moving, and we can take this hydrogen atom, the nucleus at this hydrogen atom, or the proton at this nucleus will be at rest. So this is how we can explain that motion also. But sometimes we need to correction. We will see later on in atomic physics that we need some correction for this also. So we will see later on. But if you talk about the positronium ion, then the scenario will be changed, because in positronium ion what will be happen? So here will be just E plus and this is E minus. So here you have the same mass of this positron and electron, because they are antiparticle to each other. So in that case, if you take this as mass me and this is also mass me, so your mu will be what? Your mu will be just me into me divided by me plus me, that will be me by 2, and in that case your position vector will also be, your center of mass will also be at the middle point. So you have to take the motion of this point. This is the equivalent point, equivalent system. Okay. So there are many such kinds of system we can explain with the help of the concept of reduced mass, that is nothing but the equivalent one body system for two body problem. Okay. So in the next class we will discuss about the properties of central force, but this concept is very useful. We will use this concept again when we solve problems. But before that, we will like to continue the discussion of the central of mass, central force, and we will discuss in the next class about some properties of central force. Okay, thank you.